Hi friends, today let's compare the molecular geometry between three important molecules such as methane, ammonia and water using hybridization concept. So first of all, let's take the molecule CH4, methane, and carbon is a central element, and let's write the electronic configuration, the ground state configuration, which is 2s2, 2p2. Because we know that carbon's atomic number is 6 and its electronic configuration is 1s2, 2s2 and 2p2. But as because of hybridization is the concept of intermixing of atomic orbitals present in the valence shell. We take only the valence shell configuration, that is 2s2, 2p2. And this is how we are drawing the atomic orbital, 2s2, 2p2. Next step is to write the electronic configuration in the excited state. So that one electron from 2s will be moving into 2p. It makes the configuration 2s1, 2p3. This is how we are representing. Now there are 4 atomic orbitals present in the valence shell. 1 s orbital and 3 p orbital. It hybridized to form 4 hybridized orbital. So the name of the hybridization is sp3. Why? Because 1 s and 3 p orbitals are participating. So this is how we are representing the hybridization. sp3 hybridization with 4 hybridized orbitals. And the hybridized orbitals are having equal symmetry and energy. Since there are 4 hybridized orbitals, this is how we are representing the hybridized orbital diagram with 1 electron. Like this, 4 hybridized orbitals are there. 1, 2, 3 and 4 hybridized orbitals with equal symmetry and energy with 1 electron in each atomic hybridized orbital. Next step, these hybridized orbitals will align in such a manner so that to reduce repulsion, so they will maximize the distance. So as per the molecular geometry, in which way they can maximize the repulsion, electron pair will be tending to align in such a way. As because of 4 electron pairs, the best possible arrangement is tetrahedral molecular geometry. The skeletal geometry will be looking like this, having the bond angle 109.5 degree. So we need to arrange these hybridized orbitals in this way. So I'll arrange, this is the first one, second, third and the fourth hybridized orbital with 1 electron in each. So this is the hybridized orbital diagram of carbon atom. We are discussing about CH4. There are 4 hydrogen atoms. And we know that hydrogen is having 1s1 configuration. So s orbital is a valence shell and it is spherical. There are 4 hydrogen atoms, and in this case for carbon there are 4 hybridized orbitals. So each s orbital of hydrogen atom combines with the hybridized orbital of carbon. So the orbital overlapping will be taking place like this. And hydrogen is sharing its electron with the carbon atom. So as a result of this merging of atomic orbital, we will get sigma bond. This is like end-to-end overlapping. It leads to sigma bond. So we get 4 carbon hydrogen sigma bond. So the shape of the molecule will be like this. CH4, which is 109.5 degree bond angle. This shape is called a tetrahedral geometry. So now that is about CH4, and now let's compare this molecular geometry with the ammonia. So again we have to start with the electronic configuration of nitrogen. Nitrogen's atomic orbital configuration in the ground state is 2s2, 2p3. Electronic configuration orbital diagram is this, 2s2, 2p3. And now in the excited state of electronic configuration is always depends upon the number of elements attached with the central atom. So here in ammonia, there are 3 hydrogen atoms, 1, 2, 3. 3 hydrogen atoms are there. So for each hydrogen atom, 1 unpaired electron is enough. It means total 3 unpaired electrons are enough. So here we have 1, 2, 3 unpaired electrons. So in this case, we don't need to do the excited configuration. So ground state electronic configuration itself is required for the hybridization. But in the previous case for CH4, When we write the electronic configuration in the ground state, 1, 2, only 2 unpaired electrons were there. But hydrogen atoms are 4 in number. So we need 2 more. So that excitation was required in CH4. In this case, excitation is not required. So 2s2 and 2p3 configuration is enough to take for the hybridization. Now in the valence shell, 1 s orbital is there and 3 p orbitals are there. So the hybridization is again sp3 only and having 4 hybridized orbital, but the difference is out of this sp3 4 hybridized orbital, one hybridized orbital is having paired electron. The remaining 3 are having unpaired electrons. It means if we draw the hybridized orbitals separately, I am drawing the hybridized orbital separately. The first hybridized orbital is from 2s2 with 2 electron, the remaining 3 with 1 electron. Single electron in each hybridized orbital. So the one hybridized orbital with a paired electron will act as lone pair. The remaining 3 will be acting as bond pair, because those bond pairs will participate in hybridization and leads to the bond formation with the hydrogen atom. Okay, so these are the 4 hybridized orbital. Now to minimize the repulsion. These hybridized orbital will be aligning with the maximum distance. So normally we may think about the tetrahedral geometry only. This is a normal tetrahedral geometry behavior to minimize the repulsion. But the difference between this molecule and the previous molecule, in CH4 there was no unpaired electron. There was no lone pair. But in this case there is a lone pair. So that to minimize the repulsion, there will be lone pair bond pair repulsion is also there along with bond pair repulsion. Means this bond pair will repel, this bond pair will repel. At the same time this lone pair and bond pair also will repel. But CH4 there was no lone pair bond pair repulsion. So to minimize the repulsion between lone pair and bond pair, these two, the distance between the lone pair and bond pair will be maximum. And the distance between bond pair and bond pair will be minimum. So that there will be a change from the normal tetrahedral behavior to another geometry which is called a trigonal pyramidal geometry. Trigonal pyramidal. And I will draw how to represent the trigonal pyramidal geometry. The lone pair will be like this, and the 3 bond pairs, the hybridized orbital will be aligning in this way. So here this apex is having 2 electrons, that is the lone pair, and the remaining 3 will be having 1 electron. Now hydrogen, NH3, 3 hydrogen atoms are there. Each hydrogen atom will overlap with the hybridized orbital of nitrogen atom in this way. So there is no orbital overlapping with the lone pair. Only the bond pairs will be overlapping, so that hydrogen will give 1 electron to each hybridized orbital, leads to the formation of sigma bond, which is NH3. So this is how the molecular geometry looks like, which is called a trigonal pyramidal geometry with the bond angle 107 degree. So the difference between CH4 and NH3 is there is a difference in the molecular geometry because of the presence of 1 lone pair in NH3. But the hybridization is same. In both the cases it is sp3 only. But here 1 lone pair is also there, so that the geometry becomes trigonal pyramidal. Now let's take water. In water, oxygen is a central atom. Oxygen. And the ground state configuration is 2s2, 2p4. So the electronic configuration orbital diagram will be in this way: 2s2, 2p4. So here in 2p4, 1 orbital with the complete paired electron, the remaining 2 with the unpaired electron. Now we have to see how many unpaired electrons are there. There are 2 unpaired electrons, so that those 2 unpaired electrons are enough for these 2 hydrogen atoms. So that no need of any excited electronic configuration. This itself is the configuration. Now hybridization. This 1s orbital will combine with or overlap with 3p orbital forms sp3 hybridization. Same hybridization only, but the difference is s there is 1 orbital, in p there are 3 orbital. So total sp3 hybridization with the 4 hybridized orbital. The difference is this is the first one, second one, third and fourth. The first two will be lone pairs because the paired electrons are there. Last two will be having unpaired electrons. So that acts as a bond pair. These two are bond pair and these two makes a lone pair. So two lone pairs and two bond pairs are there. So in this case, there will be three kinds of repulsion: lone pair repulsion, lone pair, bond pair repulsion, and also bond pair repulsion. And according to VSEPR theory, it is telling like lone pair repulsion is maximum. The repulsion, as because of maximum repulsion, the more effective repulsion, the distance between lone pair and lone pair should be maximum. The distance between bond pair and bond pair will be minimum. So the bonded pairs of oxygen atom will come closer. The lone pairs will be moving far apart from each other. So we are expecting it is like a tetrahedral geometry only because of 4 electron pairs, but that geometry will be changing into bend. The geometry will changing into bend and the structure will be this: 1, 2, 3 and 4. These two are the lone pair and these two are the bond pairs. And the hybridized orbitals present in this oxygen with one electron overlap with hydrogen atom. Hydrogen atom, and hydrogen is sharing its electron with the oxygen atom, so that we get oxygen, 2 hydrogen atom, it forms sigma bond and with a lone pair. 2 lone pairs and 2 bond pairs. So here in ammonia, 1 lone pair and 3 bond pairs. So when you compare the 3 molecules like methane, ammonia and water, the difference is in all the 3 cases it is sp3 only. Hybridization is sp3 only, but the difference is there in the bond pairs and lone pairs. In CH4, there are 4 bond pairs, but in NH3, 3 bond pairs and 1 lone pair. In water, 2 bond pairs and 2 lone pairs. Because of that number of lone pairs, the molecular geometry is also different. CH4 is tetrahedral geometry, NH3 is pyramidal or trigonal pyramidal geometry, and water is bend. So the bond angle is also different. Tetrahedra is 109.5 degree, pyramidal is 107 degree, and bend is 104.5 degree. So this is because to minimize the repulsion between lone pair and lone pair in water, lone pair and bond pair repulsion in ammonia, and bond pair repulsion in methane. So this is how we are explaining the molecular geometry between these 3 molecules using hybridization as a concept. So I hope you understood. Thank you all.